welcome and good morning from my side. Thank you very much for the introduction. And yeah, today I would like to give you an insight on digital smart nameplates, physical nameplates with using QR code and or RFID, NFC. And yeah, my name is Florian Geith. I work for smart-TEC. We were founded in 1999, so we have experience for over 25 years now in manufacturing identification solutions, QR code, RFID, NFC, and others. And to start with, we need to know what is Auto ID. In English, the abbreviation is AIDC. It stands for Automatic Identification and Data Capture. And therefore, products are given a specific code that can be automatically read by an electronic device. It can be a scanner, it can be your smartphone. And Auto ID is suitable for all areas of application in which data is collected and also analyzed. The components, the assets or equipments can easily be identified by different labeling solutions. Can be a sticker, can be some plates or whatever. And by automating the data entry and retrieval, it improves the operational efficiency, the accuracy and the security. And Auto ID technologies are all over in our daily life, privately and also in business. There are some state-of-the-art technologies which we might all know. Barcodes, of course, biometry, when you unlock your smartphone, for example, voice recognition, smart home device is functioning with your voice. Magnetic reading stripes, radio frequency identification, OCR, so optical character recognition, electronic article surveillance, so this is known in retail stores. When you go out the store and you don't pay, the alarm goes on. Real-time location systems is known via car sharing, for example. Today we focus on barcodes and RFID, radio frequency identification, since those are two major Auto ID technologies very suitable for the DPP and also for the AES. We all are aware, I guess, and we know that the DPP is coming. There is a proposal from the European Commission for the ESPR that the information given is about a specific product. This information will be accessible only electronically, and therefore there is a digital data carrier needed via a unique identifier. And this data carrier needs to be present on the product. And for the information itself, there are also some requirements, and this is covered more or less by the AAS. It's an open standard. The information needs to be machine readable. It must be structured and searchable for all parties that are involved in this whole process. And another standard, we heard it in the last presentation, is the IEC 61406, and there's one part, so the very beginning is the identification of a product, the identification of an object with a unique and memorable marking. You can see it in the lower picture. There's this frame with this triangle in the corner, which indicates that this product is according to the IEC 61406. And if a product has several barcodes or other identification methods, then you know, okay, this one is the right one to choose, to scan, and I get the information that I want. And of course, the information can be read by using your commercial iPhone or phones, smartphones, or any tablets. Meanwhile, every tablet is equipped with cameras, NFC tag readers, and so on. Yeah, QR codes, as mentioned, this is one of the technologies. QR stands for quick response, so it's working very quickly. And it was developed back in 1994 by DensoWave. And QR code is also called a 2D barcode, 2D because it's working in two directions, up direction and in the vertical direction. And it always consists of a square matrix. So you have dots, black dots, and white dots or spaces. These are called modules, and these modules represent the encoded data inside. The purpose of the QR code was to have more information in less space, compared to a 1D barcode, which is this stripe code, and having a higher reading tolerance, also in case of faulty code. So when you have a scratch in it, there's a tolerance so that you can still read it. And typical applications, there's one behind. You can scan the code and get the agenda, or payment terms, mobile ticketing, restaurant ordering, loyalty programs, and product tracing, and there are many, many more. RFID is the second technology. RFID, radio frequency identification, is more or less an umbrella technology. So you have three major sub-technologies, starting at a frequency band. So the low frequency band, it starts at 120 kilohertz. Then we have the high frequency HF, working at 13.56 megahertz. And in the upper range, we have ultra high frequency, starting at 868 for the European market and ends at 915 megahertz for the US market. We concentrate on NFC. NFC works in the HF range at 13.56 megahertz, and NFC is also well known, stands for near field communication. You use it when you pay in the supermarket, for example. It is in passive and contactless identification, so there's no battery inside an NFC tag, there's no power supply. It's function like energy harvesting, so the tag uses the energy of the reader to get to exchange the data, and the tag has a memory bank, always to store the information, an ID link or some other information. Commercial available memory sizes are between 4 bytes and 8 kilobytes, so quite big. This is how the tag looks like from the inside, and basically all RFID tags are built up the same way. You have an integrated circuit, an IC, it's a chip, and around this chip you have the antenna. Both components are combined together. It's called inlay. The chip and the antenna are bonded together. And when you put a housing around the inlay, in terms of a foil or a hard plastic housing, then you have the tag. And in German we call it also transponder. But those are the main words for the RFID tag. Also typical applications are also widely known, and I think every day you're confronted with it in location tracking, access controls, logistics, inventory management, animal tracking, marketing, vehicle access, theft prevention, race timing. So there are a lot of RFID applications that are also used to it without maybe knowing. But it's a standard application meanwhile. And of course, QR code and RFID, you can compare it very, very good, since there are a lot of matches, but also some advantages and disadvantages. And of course, the major one is the price. QR codes are more or less for free. You can print it yourself on the existing blade, print it out with your printer, or laser it directly on your product. But there are also some advantages, of course, not only price-wise, the disadvantages for RFID, NFC. So once you have a harsh environment where the QR code is not suitable anymore because of dust, because of dirt, because of darkness, because of mechanical influences, the RFID NFC tag can be still readable. It does not need light, it does not need visual contact. So here are some examples of our portfolio. These are our industrial tags. You can see some small plastic tags, robust plastic tags, which are usually used for existing nameplates. So these are add-ons for existing physical nameplates. They're very robust and used in chemical industry, in construction industry, and are very flexible with regards to mounting. If you would like to replace your existing nameplate and integrate RFID on it, we have the possibility to produce metal plates, so aluminum, stainless steel, everything is possible, flexible in size, in shape, layout is completely customized. Also mounting positions, mounting holes, everything can be done by customer needs. And also for explosive areas, we have a solution. We have a small selection of products which are ARTEX and IECX certified. So even if you have areas where ARTEX is not covered, so like Southern America or Northern America, we have experience registering or approving those tags also for in Metro in Southern America, FM approval in Northern America, also China, Australia. There are some experience, and yeah, we are happy to assist you there. Yeah, and that's it for the presentation for Auto ID technology. And if there are any questions, please let me know. Thank you very much.